Cool.
Thank you, Hal. Thank you, and good morning. Welcome. I'm Terry DeWeese with TCNet. We're a small network design company located in Kansas City. This morning we would like to present two networks to you for consideration and implementation. First network for consideration is the Alpha network you'll see on the slide here. It's a network, basic network, function with growth potential. It's designed as single port, single domain structure. The second domain to present is the Omega domain. It's a network designed as a parent-child domain, and it is a potential for growth in a single forest and single domain structure. The TCP team will be presenting the similarities of the two networks while showing the advantages of the Omega network. So with this being said, I'd like to get the presentation started, and we'll start it off with Colton. Colton will be talking about IP DHCP relay. Take it away, Colton.
Thank you, Terry. My name is Colton Croyson, and I will be talking about our network ranges as well as how we are going to be distributing those throughout our different options. For all computers to communicate, they need an IP address, which is a set of numbers that represent where a computer is, similar to a home address. For Kansas City, we will be using a private Class B CIDR 16 subnet range, which is large enough for current use as well as for future growth. All the child domains, because they're smaller, will be using a private Class C CIDR 24 subnet range. We could assign these IPs individually, however, this would take more administrative support and runs a risk of errors due to mistyping. So we will be using the Dynamic Host Configuration Protocol, also known as DHCP, which is a role provided in Windows Server 2012 R2. It will distribute the IP addresses to the client machines automatically. It will also hand out the information for the default gateways, the WINs, as well as the DNS. The DHCP distributes these addresses through a broadcast protocol known as DORA, which is displayed in the center of the slide behind me. Unlike the clients, the servers will be statically set, and due to these static addresses, we will exclude the first 15 addresses and the last 5 addresses on the DHCP scope to avoid any conflicts. We will also be setting reservations for the use of printers, and that will be set using the MAC addresses from the printers. In Kansas City, we'll be setting aside 25 IP reservations, and all the other cities will be setting aside 15. In Option Alpha, we'll be using an 80-20 split scope across the WAN to provide fault tolerance. This is, for example, Kansas City will be split with Detroit, Detroit will be split with Chicago, and then Chicago back to Kansas City. For this to be possible, we have set up a DHCP relay agent on the router. In Option Omega, since it has 2 member servers running DHCP, they will be using a 50-50 load balance failover, so that in the event of a service failure, the second server will continue to distribute the IPs. Now that we have a means to distribute the IP addresses, we will still need to be able to resolve machine names to those addresses. And on that note, I'll now hand you over to Jack, who will talk to you more about WINs and NetBIOS. Okay.
Thank you, Colton. Good morning, my name is Jack Taylor. Talk to you a little bit about WINs, and in order to understand anything about WINs, you probably need to understand NetBIOS. NetBIOS stands for Network Basic Input-Output System, and it's an old name resolution method which relies on broadcast traffic. The most important reason that it continues to exist is that it allows older legacy applications on separate computers to communicate over a local area network. NetBIOS is not a networking protocol. Instead, it's a software interface and a name convention. WINS stands for Windows Internet Name Service. It runs on a Windows server, and it's Microsoft's solution for NetBIOS name service. It's an interface for NetBIOS. It stores NetBIOS registered names, and their corresponding IP address resolutions. It allows NetBIOS to provide services to those legacy applications. In our example, if you look at the alpha build, WINS is implemented on a single member server at each location. That makes it impossible to perform replication. On the Omega build, WINS is installed on 2 member servers, which each server established as a replication partner for the other in a push-pull configuration. Push will occur after each 15 changes have occurred, and pull will take place every 3 hours from midnight or 8 times a day. NetBIOS over TCP/IP, sometimes referred to as NBT or NetBT, is a networking protocol which sends the NetBIOS data over the transmission control protocol or the user datagram protocol. This allows legacy computer applications relying on the NetBIOS API to be used on modern TCP/IP networks. NetBIOS is less capable than the more robust DNS name resolution. For example, NetBIOS is not able to resolve names over the internet. The more robust solution, DNS, will now be covered by our next presenter, Mr. Robert Daniels. Thank you.
Thank you for that explanation of WINS, Jack. My name is Robert Daniels, and today I will be outlining the implementation of DNS, another method of name resolution, in our Alpha and Omega networks. DNS, or the domain name system, resolves fully qualified domain names to IP addresses and back through the use of forward and reverse lookup zones. There are 3 types of these zones. Primary zones hold the master writable copies of all the records for the zone. Secondary zones are read-only copies of all the records found in those primary zones. And stub zones hold the SOA, NS, and A records for the name server's authoritative to the remote domain. As an alternative to stub zones, you can also use conditional forwarders to relay requests to a remote DNS server. Now, in both of our network options, we are implementing Active Directory integrated primary zones, which allow for multi-master DNS and allow the replication to occur as part of Active Directory instead of a separate zone transfer process. And they also allow for secure dynamic updates from DHCP. Now, in our Alpha network, as you can see, we have one primary zone for the United States and another primary zone for Europe. And we will be using stub zones to resolve names across those 2 domains. And moving on to Project Omega, we have multiple domains per forest. Resolution between domains inside the forest will be taken care of by forwarders and delegation that is automatically set up when you create the child domains. To resolve across the forest, we will be setting up conditional forwarders from one parent domain to the other. Now, DNS is an important service both for the functionality that it provides and also as a requirement for Active Directory to function. And I'd now like to invite Mike up to give an overview of Active Directory.
Thank you, Robert. Hello, my name is Mike. Today I'm going to talk to you about Active Directory, Forests and Trusts. Active Directory is a collection of users, computers, groups, and objects controlled from a centralized point. We decided to go with Active Directory over a workgroup simply because a workgroup is used when you have 10 or fewer local machines and no centralized admin. When installing the Active Directory feature, the DNS role is automatically installed. The Active Directory is dependent on the DNS role to function correctly in this application. Within the Active Directory, objects are organized into a hierarchy that uses the OU structure that Kurt will discuss. A forest can contain one or more domain controller structure, global catalog, directory schema, and directory configuration, as well as an automatic 2-way transitive trust relationship. Also can be defined as a collection of domain controllers that trust each other, that units of replication, security boundaries, units of delegation. Trusts allow Active Directory objects to access resources in other domains. Computers within a domain allow Computers within a domain allow users authenticated by the domain controllers to access their resources. Trust can consist of one-way external, a two-way transitive or non-transitive trust. Implicit trust is from a parent to child domain. It is automatically set up when you make a parent-child relationship. Inside the Active Directory, we have the ability to use a couple of different ways to set up the OUs, some of them being the Active Directory Admin Center, the other being Active Directory users and computers. This function is new to Server 2012 R2. One of the new features is the user-friendly taskbar that allows the ease of manually inputting OUs, groups, and users. In our first option, Alpha, we have a dual single forest, single domain. This allows us to keep it simple, allows us to manage permissions in a central location, also allows us to manage each system using group policy objects, which Miranda will be covering. Also provides an additional Active Directory dependent services. We're using two one-way external trust, making sure we have domain-to-domain access to objects. The Omega option provides for a much more complex parent-child forest. Within the same forest, the parent-child domains have two-way transitive trust automatically created during the promotion of the first domain first DC in each domain. The Active Directory structure for each domain will be similar to the Alpha option with the same OU structure. As the company grows and the need for more levels of children domain, we can implement shortcut trust that can be created directly between two children domain. And with that, I'm going to hand you over to Kurt, who's going to tell you about OU and naming structure. Thank you for your time.
Thank you, Mike, for that great introduction to our domain structures. Hi, I'm Kurt McTaggart, and I'll be discussing the OU structures and the items within. With the foundations to our networks laid, we need to place the building blocks so that our users can access the resources they need to do their jobs. The OU structure is used to ease administrative tasks and increase security with our domain by a series of hierarchical groupings. Within this structure are the objects that are uniquely identified by their distinguished name, which is the path to that object. Initial objects are the default containers that are created at the promotion of the first DC. We have further defined the structure by the use of organizational units that contain similar objects, namely users and computers. As domain administrators, there is a choice to retain control of that OU or to delegate control out to other IT staff or departmental management, as the case may be. GPOs, which will be detailed later by Miranda, can also be applied directly to these individual OUs instead of the entire domain, giving us a finer grain of control and security. Groups, much like OUs, aid in the organization of users. Here we are using the security group type, which generates a unique security ID for the related to that group at creation for use in assigning permissions to the objects or the resources in the domain. We'll be implementing global groups containing specific users that are related by the user's department, job description, and role. These global groups will be nested within the domain local groups to allow accesses to domain resources, of which the most common example is file and folder permissions. We are using a naming convention to define a standard way of labeling these items for ease of identification. Both of our options will be using this naming structure and this naming convention and OU structure with a slight modification